on the left-hand side, we have the Jupyter Lab view that we're familiar with. Now, what I'm going to show here, obviously, it can be done anywhere. It doesn't have to. It can be done on your local machine. It doesn't have to happen right in the cloud. And on the right, I have the Learning Resources web page. And on the Learning Resources web page, there's a under the pre-event prep header, we have the Git menu, and there's all sorts of discussion about Git and GitHub. And GitHub is a cloud repository that uses the Git technology. You can use Git elsewhere. Some things to point out is it's a very, very powerful tool. It's also it can be very confusing. And like Christina said, there's philosophies around the use of Git. So we're not going to get into any of that, and I'm probably not the right person to talk about that. What I'm going to do is just skip down to how to use it for these projects. There's a couple different ways, and the first one is outlined in section 4 here, using this branching technique. But we're not going to talk about that one. I'm going to talk about a slightly different approach using forks, because it sounds like that's what some of the groups are using. And also, I've been convinced that this might be a way to reduce merging conflicts and stuff like that.
Hey,
so
Tony,
yeah.
a brief chime in while you're on that screen. You see that note, that blue note right below the image, the forking get flow? I really recommend that link, that article. The person, Felipe, who did our survival guide for Ocean Hack Week, found it. And we both agreed it was a fantastic, very detailed and practical guide for what Tony's going to be talking about. So,
fantastic.
As a follow-up, and Tony, if you feel like it, you can click on it at some point. I just recommend it to people. That's all.
Great. Yeah. So this is what it looks like. That sounds fantastic. So take a look at that. We can maybe take a look at that at the end as well if we need to. But the general idea is, maybe that's what this top figure is showing here, is that you have all of your code, and this is database figure, this little cylinder, all of it lives somewhere. You have a whole team of people that are all trying to contribute to the same code, right, or the same project. That's the whole point of version control. What the forking approach does is it separates that, so everybody has their own copy of that space, of that source code, and then they all are contributed into that main code base using forks. And that might sound a little confusing, so what I'm going to do is just scroll on down to this figure right here. So this, I think, really summarizes what's happening. We have our main repository here on the top left. This is the thing that that was created. I'm going to show one right here. Maybe we'll move this guy over here. This is the Waterhackweek 2020 Snow and Groundwater Group. This is the repository that was created by the group. That's the main repository that's in the top left corner. So I want to be able to pull from that, but I don't want to be pushing my changes into this because there's only 4 or 5 people all together trying to commit their changes. So if we use the forking model, what we'll do is we'll make a copy of this repository, and that's shown in the top right. This is what's called the personal fork. So I'm just going to go through that. I just click fork on the top right corner, and I'm going to fork it to my account. And if you're part of multiple organizations, you might see those as well. Right. So what this is doing is literally making a copy of that repository at that point in time. And something you may notice here is that now the repository, instead of saying, originally it said Waterhackweek, WHW 2020 Snow Groundwater, now it says my username / WHW 2020 Snow Groundwater. So this is my own repository. I can do whatever the heck I want with it. It actually doesn't affect the forked repository. So if we think about this kind of like a fork in the road, right? We could potentially just go in a totally different direction and never look back. What we want to do is kind of go parallel and move our code back periodically. So this is what we want. Okay, so now we have our own repository that nobody else is touching. So what we'll do is, so we have these two, the top left and the top right of this diagram filled up. Let's start working on it. In order to do that, we need to clone this repository somewhere to work on. So what I'm going to do is I'm going to just click this code button and copy the URL. It looks well, it looks like this. So I'm going to copy that URL. And I'm in the Jupyter lab here. So this is where I want to work. You can do this locally as well. So I'm going to open up the terminal. And if I list the files and folders, I have a few different, it's a pretty messy looking directory, but I have a folder called Waterhackweek. So I'm going to go into Waterhackweek.
Hey, Tony,
and,
how about increasing the font
yes,
in the browser?
That's good. Oh gosh, that was the wrong.
Can I also ask everybody who is not talking to mute? There's a lot of extraneous noise coming through.
Okay.
Not you, Tony.
Okay. Can I increase the font in here?
I always just do the browser font, the Control+.
Okay, so that was messing up on my other. Here, let me just do this.
Okay, whatever works.
Yeah, we'll just keep clicking this button. Or is that as high as it goes? Here, we'll just make it bigger. Oh, I know why. It's messing with another window because I have the same Jupyter Lab open on my other screen. Okay, that's fine. All right, so so this is what it looks like now. Is that better? Font-wise? I think that is yes.
Yes.
So okay, great. So all I did was I moved into this Waterhackweek directory, and then I listed the files and folders in that. So we can see what you see on the directory on the left is the same as what we see in our terminal view. Okay. So this is where I want to clone the repository. So the command for that is git clone, and I'm going to paste that URL that I copied before. So it's actually the URL to the repository with .git at the end. One really important thing to notice is that I am cloning github.com/Castronova, which is my username, and then that repository. So I'm cloning my fork, which is right here, as opposed to the fork or the original repository that's Waterhackweek. So when I go ahead and grab that, and now I have that folder that pops up on my left-hand side. So I can go into that folder. So cd into Waterhackweek 2020 snow groundwater. And I'm going to clear my terminal, and I can list the files in here. So there's a few different files. So I have my local repository cloned, or my fork is cloned. Any changes I make, I can push to my fork. But the one thing I'm missing is that I'm not set up to pull down changes from kind of the main repository where we're all going to be contributing to. So that's the first thing I need to set up. And the way we can check that is just by saying git remote -v. So this is saying, hey, list all of the remote connections that my repository has. And it says that I have something called origin. It's pointing, or it's directed at this location. So this is my fork, and I can fetch. That means I can go and grab updates from that location. I can also, at the origin, at the target of Castronova Waterhackweek 2020 snow groundwater, I can also push. So that means I can move my code into that repository. So if we look at this figure on the right-hand side, what we have is we actually have a bidirectional arrow here. We can push to our personal fork, and we can pull from our personal fork. But we actually can't touch this main repository on the left. So what we need to do is set up this little pull upstream arrow. So to do that, there's all instructions inside of this learning resources. But what we're going to do is use this command, which is git remote add. So we're going to add a new remote URL, and we're going to call it upstream. And we want it to point to the original repository. So what I'll do is I'll come in here and I'm going to click on where I forked it from. So this is it's going to open up the original. And one way to double check that is just at the top left-hand side, it does say Waterhackweek, right? So let's go ahead and grab that URL. And I'm going to paste it in here. So now I have it, if I hit this, okay. I've added a remote called upstream. So we can double check that by saying git remote -v, and v just means in verbose. So I have two URLs. So I have an origin that's pointing to where I can push and pull, or fetch and push to my fork. And I also have an upstream where I can do the same thing. Okay. Now, what we're interested in on this figure on the right, we only actually want to push to our original fork, and we want to pull from the main repository. That's the pattern that we're going to kind of encourage everyone to do. And so there's ways that you can disable, say, pushing to the upstream and pulling from the origin, but we're not going to get into that. I think there's reasons for keeping them. But we essentially have created this connection that's shown on the right. So anything we do from here on out, we're all set up. Okay, so those are kind of like the prerequisite steps for getting your environment going using the forking model. So I created this collect NWM data. Now it's not done yet, but I was working on it this morning, and I'm going to add this to the snow and groundwater group. So I'm just going to drag it in here, and I'm going to create a new folder, NWM data, because this is, if we collect national water model data, there's probably also going to be a whole bunch of data, so I don't want that all going into the directory. So on the right-hand side, now if I list my files, I see my folder NWM data. I can even list what's inside NWM data. Great, I have my collect NWM data, I type my notebook. And it's really not done yet, but that's okay. I'm going to commit it to my local fork so I don't lose my changes. So this is where we get into more of the typical Git workflow, and this is probably where it's really good to look at that link that, well, actually there's multiple links in that document, but possibly the one that Amelia mentioned earlier. So one of the commands that's kind of your best friend is status. So if I say git status, it's going to tell me the status of everything that's in my repository. So up here at the top, right highlighted here, you have a list of all of the files that have been modified that GitHub knows about. And then down here it says untracked files. Okay, so you have a folder called NWM data that I know nothing about. And that's totally fine. You can have a ton of untracked files down there, and that's totally fine. But what it's telling you is if you try to make a commit, if you want to push code up to the repository, your fork, nothing down here is ever going to be included because you never told me to include it. So I want to explicitly say, add this file. I want you to add this file into the version control. So I'm going to say, use a command called git add NWM data, and that should add everything inside the NWM data file folder. Sometimes that's not good. If you have hundreds of files in there, but you only want a few of them in there, few files. For instance, if we have this script that's going to collect national water model data, we probably don't want to add the data itself because the script goes and collects it. So you wouldn't want to add the root folder. You'd want to add the files explicitly that you want in there. So let's run git status again. And now we see we have our branch is currently up to date with the origin. And if we look on the figure on the right, the origin is our personal fork. So obviously we're up to date with that. We just downloaded it basically. We have new changes to be committed. We have one new file, and it's inside of a folder called NWM data, collect NWM data.ipynb. And then we see untracked files. We don't have that header anymore because we don't have the untracked files in our directory. But I'm gonna, so git add really is just telling GitHub, hey, can you pay attention to this file? I want you to keep track of when things have been modified, or when this file's been modified. It hasn't been actually committed to, hasn't been added into our remote. So I guess I'm using add multiple ways here. It hasn't been moved into our fork here. It's still exactly the same. We can refresh this, nothing's changed. So what I'm going to do is commit this, commit and push. So one of the commands, git commit, and I can add a message. So any file that's been changed or been added, staged for change, staged for commit, is going to be committed. So I'll say, okay, the files that I've changed, let's go ahead and I want you to move them into the repository. And I want you to add this message, and you should be as descriptive in your commit messages as possible, because this is what describes every change that's going into your repository. This one is just kind of an initial version of my NWM data collection. So it's really not finished, but I want to just demonstrate this. So I will say commit. And what that's done is it's staged it for commit. So it hasn't actually moved it. You have to tell Git to explicitly push that you want to move this into the forked repository. So I'm going to say push. So push it to the server. And I have to enter my username and password. Now, those things, you can have it, those saved, and there's instructions in the learning resources, actually right at the top for adding that so you don't have to add your username every time. So that's been pushed. So let's take a look over here. So if I refresh this page, we see the branch is one commit ahead of the Waterhackweek, the main one. And the last commit was 43 seconds ago by me. Now, how do we contribute? So let's pretend that we have this ready. We have some chunk of code that we want to contribute back into our project's main repository. So how do we get it into this repository left? If I refresh this, nothing has changed. I've added it to my fork, but not to the main repository. So the way that we do that is we go to our fork repository and we create a pull request. So we'll say create a new pull request. And we can set the base repository is our current, I'm sorry, the base repository is the location where it's going to go. It's a little bit, makes a little more sense if it's full screen. So we're going to move, we want to move our code from the right-hand side here, the Castronova Waterhackweek 2020, into the main repository, Waterhackweek 2020. And then there's a summary of, looking down here, there's a summary of the commits, the files that were changed, there can be comments, and there's all kinds of details, and you can get, that's really helpful when you have large numbers of files that are being changed. But in this case, it's pretty simple. I'm just going to go ahead and say I want a pull request, or so create the pull request. I should say that this is the initial version of the data collection script. It is not complete, but I want to demonstrate how to issue API. Okay, so I can go ahead and create this pull request. You can tag people as reviewers. So if I specifically want someone to look at this, so I know Nina is on here, so I'm going to choose our leader, our fearless leader. So I can choose her. So she's assigned as reviewer. She'll get notified by that. But I can also just say, at Nina, can you please take a look at this and merge it here, right? So I can go ahead and do that. So she'll get more than one notification now and create that pull request. Now, if you are an admin in your repository, you can manually merge your own pull request. It's generally not good practice to do that. So if Nina decides to merge this, that's how the code will get into this repository on the left. And only when she goes in and physically says, yeah, let's move this over. And the reason for this is it helps prevent merging conflicts. So everything that you move over into the main repository is a very explicit action. It's not something you're going to do really quickly at the keyboard.
Tony, I think there's already activity in your pull request.
There is. Oh, you made a comment. This is not appropriate. Oh, great. Didn't sleep last night waiting for that notebook. Perfect. So, I mean, I tagged Nina, but Emilio could potentially merge this if we wanted as well. And then you can have full discussions in here and say, hey, Tony, there's typos all over this place. Can you fix those first? Stuff like that. Okay, so let me show real quickly. We've made this, we created the main repository, or the main repository already existed. We created our personal fork. We cloned it to the place that we are going to work with. We call that our local repository, our local clone. In this case, it happened to be in the Jupyter Hub cloud environment. That could have been on your computer or wherever you want to be working. We set up these connections, these arrows to push and pull from the different repositories. And then what we did was we made some changes, pushed them up to our personal fork, and then a pull request to the left over the main repository. And that's how we want to get our changes in. But there's going to be 5 or 6 people all doing that at once. So how do we synchronize our local repository with what's happened in the main repository? So let's pretend that someone else on this snow groundwater team now wants to get Tony's awesome changes here. So their repository will be set up exactly the same way. So if we say git remote -v, we have the 2 remotes, we have our origin, this is our fork, and we have the upstream. So what we want to do is actually, we want to fetch from the upstream. So we will do a git pull upstream, I believe is the command. So we're saying, hey, go get the latest code from the upstream branch. And we may have overwritten, no. You asked for upstream, but did not specify a branch. So I would probably want to do origin upstream, then the branch master. And it will probably give me, well, maybe it didn't do anything, or did the code actually get merged? But that would be the approach for anyone else that wants to pull down their, to synchronize with the remote branch. You can refresh this, it might have been merged in. It was merged in, right? So for anyone else, I would have expected to get an error saying, hey, it's going to overwrite files if it wasn't merged in. But if you end up having files that you change that are in conflict with the files that will be coming onto your computer, you'll get a notification. You'll say, hey, here's the files that are all that are going to be overwritten. So I'm not going to pull that down because you're going to lose your data. I'm helping you, right? So if that's the case, you want to do a Git Status and take a look at any files that you may have messed with. So I can demonstrate that by well, we can go ahead and open collect NWM data, and this is very messy. Real quick, if it loads. Let me go ahead and add a new cell and say, this is the title. You can change that to Markdown. Okay, I'm gonna save it, close this, and then if I do Git Status, okay, one of the files that the repository knows about has been modified. So what if I say, oh, well, someone else on the team has been making all these updates, and it's 8 a.m. Pacific time. I need to pull down the latest code before I get started today. So I'll do a git pull upstream master.